What if the most advanced telescope ever built has just unveiled a truth so profound it threatens to unravel the very laws of physics? What if the universe, as we've painstakingly mapped it through equations and observations, is not what it seems? The James Webb Space Telescope, engineered to pierce the veil of cosmic time, has delivered revelations so staggering that scientists are questioning the foundations of reality itself. From galaxies that defy the rules of formation to signals that challenge the nature of space and time, its discoveries are forcing us to confront an unsettling possibility. The physics we've relied on for centuries may be fundamentally wrong. What exactly has this telescope uncovered at the farthest reaches of the cosmos? And why are researchers whispering that the universe might not obey the laws we thought were absolute? Keep watching, because what you're about to hear could change everything you believe about existence. In a distant patch of the sky, where light has traveled for billions of years to reach us, the telescope captured an image that should not exist. A cluster of galaxies, shimmering with an eerie brilliance, appeared where only primordial chaos should reign. These galaxies, formed mere hundreds of millions of years after the universe's supposed beginning, are impossibly mature. Their stars burn with the intensity of systems billions of years older, their structures too intricate, their masses too vast for the fleeting cosmic moment in which they emerged. According to our models of physics, the early universe lacked the time and raw material to forge such complexity. Yet there they are, defiant, as if mocking the equations that have guided our understanding for decades. These are not mere anomalies, they are a direct challenge to the timeline of creation itself. The deeper scientists peered into these cosmic rebels, the more unsettling the picture became. These early galaxies don't just break the rules of formation. They seem to operate under a different set of physical laws. Some show chemical compositions, elements heavier than those possible in the infant universe. Others display rotational patterns that defy the expected dynamics of gravity at such an early stage. One galaxy in particular stunned researchers with its magnetic fields, far stronger than anything predicted for that epoch. These fields should have taken eons to develop, yet they pulse with a strength that suggests an unknown mechanism at work. It's as if the universe, in its earliest moments, was already bending rules we thought were universal, hinting at a physics we've never encountered. This isn't the first time the telescope has forced us to question our assumptions, but it's the most profound. Beyond these impossible galaxies, it detected something even stranger, light that appears to move faster than it should. According to Einstein's theory of relativity, nothing can exceed the speed of light in a vacuum. Yet, in certain regions of the cosmos, the telescope has observed light signatures that suggest an acceleration beyond this cosmic speed limit. These aren't errors or illusions. The data is clear, precise, and repeatable. The implications are staggering. If light itself can behave in ways our physics forbids, then the very framework of space and time may be flawed. Could the universe operate under rules that shift, depending on where or when you look? To grasp the magnitude of this discovery, we must consider the concept of cosmic expansion. The universe is stretching, pulling galaxies apart as space itself grows. This expansion sets a boundary, a cosmic horizon, beyond which light should never reach us, as objects recede faster than light can travel. Yet the telescope has captured signals from beyond this edge, faint, ghostly traces of light that should be forever lost to us. These signals carry spectral patterns that don't match any known stellar or galactic phenomena. They flicker with an eerie consistency, as if originating from a source that exists outside the boundaries of our expanding universe. Scientists are now forced to ask, are we seeing the echoes of a cosmos that operates beyond the laws we know? The telescope's revelations don't stop at light and galaxies. In its quest to map the early universe, it uncovered gravitational anomalies that defy explanation. Massive structures, invisible to the eye, exert forces strong enough to warp the fabric of space-time around them. These aren't the familiar effects of dark matter, which we've long struggled to understand. These anomalies suggest a presence, something with immense gravitational pull, but no detectable mass. Researchers are calling them phantom wells, regions where space-time bends as if pressed by an unseen hand. The chilling possibility is that these wells are not part of our universe at all, but intrusions from a reality where gravity behaves differently, where the rules of physics are not our own. These discoveries are pushing scientists toward a radical rethinking of the universe's origins. The Big Bang, the cornerstone of modern cosmology, assumes a singular moment of creation, a point where time, space, and matter burst into existence. But what if this model is wrong? The telescope's data suggests structures and phenomena that could not have formed in the brief window after the Big Bang. Some researchers now propose that the universe might not have a single origin, but could be part of a cyclic process where one cosmos collapses and another emerges, carrying traces of its predecessor. Others speculate that our universe is a fragment of a larger, multi-dimensional reality, where different regions obey different physical laws. If true, the telescope may have glimpsed the seams of this cosmic patchwork. Among the most haunting discoveries is a faint, rhythmic signal buried in the telescope's data. Unlike the random noise of the cosmic microwave background or the pulses of distant stars, this signal repeats with a precision that defies natural explanation. It's not a star, not a black hole, not a known cosmic event. Its pattern is mathematical, almost deliberate, as if encoded with intent. Some scientists, hesitant to leap to conclusions, suggest it could be the signature of exotic particles, matter that exists outside the standard model of physics. Others, more daring, whisper that it resembles a signal from a source beyond our universe, a beacon from a reality governed by laws we cannot comprehend. Whatever it is, its presence challenges the randomness we've always assumed governs the cosmos. The telescope's findings also hint at a deeper mystery, the behavior of time itself. In certain regions of the distant universe, the light we observe carries timestamps that don't align with our understanding of cosmic history. Some galaxies appear to emit light that suggests they existed before the universe itself began, an impossibility under our current models. This paradox has led to speculation that time, as we know it, may not be linear or universal. Could time loop, fold, or fracture in ways our physics cannot yet describe? If the telescope is seeing light from a before that shouldn't exist, we may need to redefine not just the universe's beginning, but the nature of time itself. These revelations are forcing us to confront the limits of our knowledge. The laws of physics, gravity, electromagnetism, quantum mechanics, were built on observations of our local universe. But what if those laws are not universal? What if they are merely a subset of a larger, more complex reality? The telescope's data suggests that the farther we look, the less our physics applies. Galaxies spin too fast, light moves too quickly, gravity bends too strangely. Some theorists now propose that our universe is a kind of bubble within a larger multiverse, where each bubble operates under its own physical rules. If this is true, the telescope may have pierced the edge of our bubble, glimpsing a reality where our laws of physics are irrelevant. In a particularly chilling observation, the telescope detected a phenomenon that defies all known models of cosmic evolution. A distant galaxy, observed at the edge of the observable universe, appears to be aging in reverse. Its stars grow younger, their light spectra shifting as if time itself is unwinding within its boundaries. This isn't a trick of optics or a miscalculation. The data is consistent across multiple observations. The implications are profound. If time can flow backward in one corner of the cosmos, then our understanding of causality, the idea that cause precedes effect, may be an illusion. The universe may not be a single coherent system, but a tapestry of competing realities, each with its own version of time and the physics. These discoveries are not just scientific puzzles, they carry an emotional weight. For centuries, humanity has sought to understand the universe through reason, building models that explain the stars, the planets, and our place among them. The telescope's revelations threaten to upend that certainty, replacing it with a humbling truth. We may be strangers in a cosmos far stranger than we imagined. The galaxies that shouldn't exist, the light that breaks the speed barrier, the signals that hint at other realities. These are not just challenges to physics, but to our sense of belonging. If the laws we've trusted are not universal, then what are we? Are we inhabitants of a single, orderly universe, or are we adrift in a chaotic multiverse where nothing is certain? The telescope's most profound discovery may be its ability to reveal our ignorance. Each new image, each anomalous signal, chips away at the illusion that we've mastered the cosmos. The galaxies that defy time, the light that outpaces our laws, the gravitational wells with no source. They all point to a reality far larger, far older, and far more complex than we've dared to imagine. Some scientists now argue that we're not just seeing the edge of our universe, but the boundary of something greater, a structure that encompasses our reality and others we cannot yet fathom. The telescope has become a window not just to the stars, but to the limits of human understanding. As we grapple with these revelations, one question looms above all others. What does it mean for us? If the physics we've built our world upon is only a fragment of a larger truth, then every assumption we've made about space, time, matter, and existence must be re-examined. The telescope has shown us that the universe is not just vast, but unpredictable, governed by rules that shift and bend in ways we cannot yet grasp. It's a humbling, exhilarating, and terrifying realization. We stand at the edge of a cosmic precipice, staring into a reality that may not belong to us. The telescope was built to answer questions, but it has given us something far more profound, a glimpse of a universe that defies our every expectation. The implications of these findings extend beyond science into the realm of philosophy. If our universe is one of many, each with its own physics, then what is the nature of reality itself? Are we bound by the laws of our cosmic bubble, or can we one day transcend them? The telescope's discoveries suggest that the universe is not a static machine, but a dynamic, evolving entity, one that might interact with other realities in ways we cannot predict. The signals, the anomalies, the impossible galaxies, they are not just data points, but invitations to rethink our place in the cosmos. They challenge us to ask whether we are observers of a single universe, or participants in a multiverse where every rule can be rewritten. In its final haunting observation, the telescope captured a light signature that defies all explanation. A faint glow emanating from the farthest reaches of the cosmos appears and disappears in a pattern that mirrors no known phenomenon. It's not a star, not a galaxy, not a black hole. Its spectrum is pristine, untouched by the chaos of cosmic evolution, as if it were a remnant of something older than the universe itself. Some researchers speculate it could be the echo of a previous cosmos, a relic of a reality that existed before our own. Others propose it might be a signal from a boundary where our universe meets another, a place where physics itself dissolves into something new. Whatever it is, it carries a message. We are not alone, and we are not in control. The James Webb Space Telescope was designed to uncover the secrets of the universe's birth, but it has done something far more unsettling. It has shown us that the laws of physics, the bedrock of our understanding, may be nothing more than local rules in a vast, unknowable cosmos. The impossible galaxies, the rebellious light, the phantom wells, the rhythmic signals, the reversed time, all of these discoveries point to a reality that transcends our science, our imagination, and our sense of certainty. We built this telescope to find answers, but it has revealed a truth far more profound. The universe is not ours to define. It is a mystery, vast and untamed, and we are only beginning to glimpse its edges. So now we must ask, are we ready to face a cosmos where the laws of physics are not laws at all, but mere suggestions? Let us know in the comments. Do you believe the telescope has shattered our understanding of physics, or is it showing us a universe we were never meant to comprehend? Subscribe and turn on notifications, because the cosmos is speaking, and its message is rewriting everything we thought we knew. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up.